Alright, first of all, kinematics is the branch of physics that describes the motion of objects, how things move, pretty much. And that's pretty much half of the year. Alright, average speed is the simplest form of the study of kinematics, where we pretty much study the distance covered over a period of time of an object. The equation that we use for average speed is v equals d over t, where the v is the average speed measured in meters per second, the d is the distance covered by the object in meters, and the t is the time in seconds. Another way to calculate average speed is by taking two measurements of speed or velocity and dividing them by 2. So you have your initial speed added to your final speed divided by 2 gives you your average speed. Because you all know that when you take the average of two numbers, you divide it by 2, right? After you add them. Alright, when we think about motion, and we have a graph that plots distance over a certain amount of time, as I collect that data, I can get a graph that looks perhaps like this. This means that as time goes by, the distance that I've traveled doesn't change. So if the distance isn't changing, that means I'm not moving. Now if the distance changes, I'd say that the distance increases over time. You should have a nice relationship that looks like that. This represents that I'm moving. If my distance changing over a period of time at a constant rate, that means I have a constant speed. So, not moving, constant speed. Other things that could happen to a person that's moving is, let's say that he starts off a certain distance from a point and he starts to walk backwards. If he's walking backwards, that means that the distance or the displacement starts to decrease. Okay? But time keeps moving forward. Another thing that can happen is, instead of moving at a steady pace, I could be moving faster and faster and faster and faster. That means that the speed at which I'm moving is changing, which means that I would get a relationship that looks a little like that. Looks like a curve. So whenever you see a distance versus time graph that has a curved shape, okay, or maybe like a parabola, all right, that means that you are accelerating. And in this case, if we're talking about displacement rather than distance, that just means I'm moving backwards. Easy so far. Okay. So based on what we just learned, we could probably look at a graph of displacement or distance versus time and describe how a person is moving. This person, first of all, his distance started to increase at a steady pace. So that means that he was moving at what? What? Constant speed. Okay? Now, how about here? Distance remained at 8 at all times. So right here, he wasn't moving. No motion. And then down here, he decided he wanted to go back to where he started. So he's moving in reverse. Okay, or backwards. Easy. Alright. Let's think about it again in a different way. Now they're asking me to make calculations. Okay, if I want to calculate the average speed of an object during the first 2 seconds based on a graph, I could do it one of two ways. Since we're going from 0 to 2, I know that I'm only working with this piece of the graph right here. Okay? Now, one thing that we haven't discussed yet, okay, is that when I have a graph of displacement over time, if I want to get the speed, remember how we said that the average speed is distance over time? distance divided by time, okay, is the same thing as finding the slope of this graph. Okay? So we could solve it in one of two ways. We could just use the formula and pick a number for distance. For example, let's say that I go up here. My distance right there is 8 meters. My time is, for these 8 meters, is 2 seconds. And I find that, time is 2 seconds. V equals d over t. So V just equals 8 over 2. And my speed equals 4 meters per second. You can do it that way, or you can find the slope of this graph, which would basically yield the same results. If I find the slope of the graph, I pick, remember your slope formula? y2 minus y1 over x2 minus x1. If you don't remember this, take math again. Alright, so pick 2 points. I'm going to erase this so you can see it more clearly, all my doodles. If I pick 2 points, let's say, I don't know, let's pick 2 points randomly. Let's pick this point right here, and I don't know, let's pick this point right here. Same 2 points, or 2 different points in my graph. Okay? Y2 is going to be my y furthest up. Okay? So, or more actually, furthest to the right. If I go to the right on my graph and up, this right here is where my y2 is at. Okay? And where my x2 is at as well. So what do I have on the y-axis? Y-axis, I have 8. So I'm going to take this 8 and put it in here. Minus the y that I have on my other point. And this is my y-axis. So right here is where my y1 and my x1 are at. So on the y-axis I have a 4. 8 minus 4 over x2. What do I have on the x-axis down here? I have 2 minus, what do I have on the x-axis over here? 1. 8 minus 4 is 4. 2 minus 1 is 1. And my slope is 4. Check it out. Got the same number. So my speed is 4 meters per second. Easy. Okay. Try again. If you want, you can put it on pause right now and try it yourself, or you could watch me do it. I'm going to do it right now. Alright, calculate the average speed of the object between 2 seconds and 4 seconds. So that means I'm working from here to here. So when I look at my graph, I can highlight whatever it is I'm working with. I'm working with this piece. Now this could be tricky, but it's really not. Because if you remember from your math, what is the slope of a line that is absolutely flat on your graph? A line that is absolutely flat like that always has a slope, okay, of 0. Okay? So my speed is pretty much, my average speed is 0 meters per second. We could prove it by calculating it, but if you go back a couple slides, we determined that in a graph of distance versus time, if the object was like that, what did that mean? It meant you're not moving. So if I'm not moving, oops, back to kindergarten, moving. If I'm not moving, that must mean that my speed is no, I'm not moving, no speed. Okay? So that's easy. Let's try another. So, here we go. Now we're going to go from 4 seconds to 8 seconds, which means that we're going from here to there. Since we're working with graphs, we need to get used to calculating the slope. So when we calculate the average speed of a distance versus time graph, we should, most of the time, get used to using the slope. So we're going to pick our 2 points again. Okay? Usually it's nice to pick the first and the last point of the graph just so you don't have to think about it too much. Okay, so slope, remind ourselves, y2 minus y1 over x2 minus x1. Okay? Y-axis, right up here. Okay? This is where I'm starting, so I'm going to call this my y1 and my x1. And this is where I'm ending, so I'm going to call this my y2 and my x2. So now I just have to substitute whatever numbers I have here. Let's start with the y2. y2 is down here on my y-axis. Right down here I have a value of 0, which means that my m slope was 0 minus, what do I have on my y1? y1 is up here. On the y values I have 8. So it's 0 minus 8. And then let's work with the x's. x2, all the way down here, I have 8 minus, what do I have in x1? It's 8 again. What's wrong? No, not 8. Oops. 4. 8 minus 4, because the x is down here, man. So, m equals 0 minus 8 is negative 8 over 8 minus 4 is 4. It's the prettiest 4 you ever seen. Then m equals negative 8 over 4 is negative 2 meters per second. Now, if it seems goofy to you that your speed could be negative, all right, if you look at the graph, this graph is going down, 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 down. Whenever you see a graph that's moving down like that, you're always going to get a negative slope. And in this case, what that means is that the object was moving backwards. The velocity of the object was in the opposite direction that it was trying to move originally. That's all it means. Now, if they're just asking you for speed, later on when we get to vectors, you'll notice that this symbol doesn't matter because speed is a vector and it doesn't have direction. For now, we're okay with this. Depends on what the test question is like. So, we got a negative 2 meters per second, but since speed is a scalar and not a vector, which you'll see later, our result should be in the form of a scalar, and scalars don't have negative symbols because they don't have direction. So in the end, our average speed is going to be 2 meters per second. All the negative means is that it was moving backwards. Okay, sample problem. This is a problem you're going to try on your own. This is a good time to pause and try it yourself. Now, if you already paused it and tried it yourself, you're going to check your answer now. Alright, the graph below shows the distance traveled by an object plotted against time. And it asks, what is the distance covered by the object in the first 6 seconds? That shouldn't be too hard. It's a distance versus time graph. So in the first 6 seconds, I take a look down here. Seconds is the time. I know it's in the x-axis. So I look 6 seconds. Alright, and I want to figure out what the distance covered was. There it is. Answer to the first question, done. How much distance traveled? 6 meters. So the first question is done. 6 meters. Second question, what is the average speed of the object? We said in the previous problem that probably working with the slope is the best way to work with all these graphs. So, what is the average speed? Let's use the last point and the first point. Okay, we know that our formula is m equals y2 minus y1 over x2 minus x1. Our first point is down here, so we know that this is where our y1 and our x1 are at. Second point is up here. We know that our y2 and x2 are up here. So, how much is y2 up top? In the y-axis, I have 10. 10 minus y1. y1 is down here. I have 10 minus 0 over x2. x2 is up here. 10 minus, again, y1 is down here, and is 0. So your slope is 10 divided by 10, which is 1. Since we're looking for average speed, the units of average speed are meters per second. And that's it for graphs, I believe.